So to begin with, if we have a circle, what we have is the set of all points in a flat surface, so in a plane, that are a specific distance from a single point. Okay? So a circle is the set of all points in a plane that is a specified distance from a single point. That distance is your radius. From a single point, which is the center. Now, definition of radius then. Radius means two different things. It is a segment from the center that has an endpoint at the center and on the circle. That is a radius. But the radius is also the length of that segment. It is both of those. So the radius is a segment with one endpoint at the center of the circle and the other endpoint on the circle. A radius is also the length of that segment. The word radius refers to both the length and the segment. When asked what is the radius of the circle, usually they're talking about what is the length of the radius. If they're asking what is the segment, which is the radius, you'll kind of know from the context what is a radius of a circle, that type of thing. And you would say, oh, let's see, one of the radii is, and we would need to know the endpoints. If the center of the circle is O, very common name for a center of a circle, and this is a point A, then radius is segment OA. Yes, radius has to come from the center to the edge of the circle. Now, the center of the circle is a point. It's already kind of defined in definition of circle. It is the point in the center. Here we have a circle O. You name a circle by its center. Circle O. By its center. All right. Now in a circle, we have other segments we can work with. Any segment that has both endpoints on the circle is called a chord. So a chord is a segment with both endpoints on the circle. Since a segment that has both its endpoints on the circle has to be inside the circle, a chord is inside the circle. Now, we have a special name for the chord that goes through the center of the circle. The chord that goes through the center of the circle is a diameter. So here is a diameter, endpoints on the circle, passing through the center. Call this DE. Segment DE is a diameter. It's also a chord, isn't it? Because it has endpoints on the circle. Now, another thing about a diameter is made up of two radii. A diameter is made of two radii. Plural of radius is radii. Radius, the plural for radius, is radii. It means more than one radius. Now, just like with the radius, that word means not only that segment, but the length of that segment. The word diameter means not only the segment DE, but also the length of that segment. So the diameter also refers to the length of the segment. Now, if a segment passes through the circle, so it could be a line, it could be a ray, it could be a segment that passes through the circle, intersecting the circle at 2 points, then it's called a secant of the circle. A secant diameter also refers to the length of this segment. Okay, so a secant can be a line, a ray, a segment, any straight object that intersects the circle at 2 locations, so it passes through the circle. So a circle with center O here, a secant would be anything that passes through the circle, so it contains a chord. Here, call this point A and B.
What does that say after? Passes through the circle.
Intersecting it at two locations. So if I want to refer to secant AB, which does contain a chord, I have to refer to either line AB, the chord itself, segment AB, is not a secant. But when you have a line that goes through A and B, then you have a secant. It has to pass through the circle. You could also have ray AB and call it a secant, or ray BA. All of those are secants. So
or no, it's just
it goes completely through the circle.
The chord stops.
Exactly. So this secant contains a chord. This piece of it, segment AB, is a chord.
And then
But line AB, or ray AB, or ray BA, those are all secants. The next line that we're interested in relation to a circle is a tangent line. A tangent to a circle is a line or a ray. It could be a segment, but there is something specific about it in order for it to be a tangent. Its line can only intersect the circle at exactly one point. So a tangent is a line that intersects a circle at exactly one point. That's off track. We can talk about that a little bit.
So like just touching it.
Yeah, in order for it to be a tangent then, and intersect a circle in only one point, if I draw a random line that's a secant, in order for it to be a tangent, it has to be moved out and just barely skim the circle. A tangent intersects a circle at exactly one point. That point is called a point of tangency. And if we give this line a couple points so we can talk about it, call that point A and this point B, I would say that line AB is a tangent. To circle, and we'll call it circle O again, to circle O. And the way you would write circle O, the symbol for circle is an O with a dot in it. It's a circle, and you see the center. That's the symbol for circle. So tangent to circle O is line AB. Sorry, line AB is a tangent to circle O at B. Yes, at point B. B is the point of tangency. Now, these words that we have just used, all are true for sphere as well. Let me see if I can get it so we can kind of see everything when I move up. Okay, I think I need to make this smaller. Okay, if we're talking about a sphere, we can have all of these as well. For example, to draw a sphere, what we draw is a circle. We give it a diameter, and then and I don't mean diameter, we give it a central large circle, an equator you might say, and then we dot that behind it. Now since my board is going slow, it's kind of hard for me to draw. It's all grouped, so that would be kind of what you're looking at. This sphere has a center. We can call it center O as well. You guys will sit.
I'm sick.
You guys will sit.
Yeah, you can get us all sick.
Okay.
Yeah. I get it.
I'm almost done. If you can give me your attention just for like 5 more minutes, we'll be there. Okay. Okay. So now, here's a sphere. Oh, notice you name a sphere by a center just like a circle. A sphere is a set of all points, leave out the word in a plane, that are a specified distance, which is your radius, from a single point. A sphere is a ball shape, like a basketball, baseball, not a football, not a football. Okay? A sphere is like a volleyball, yes. It's all the points in space that are the distance of the radius from the center.
Is it golf ball one?
Kind of.
It's like golf ball. They got it.
Yep. Okay. You can have a radius to a sphere.
Is that ball?
Sigma OA is a radius.
Eyeball?
You can have a diameter of a sphere. This goes through O and has endpoints on the circle C and D. So CD is a diameter. The diameter is made of 2 radii, OC and OD. So now I have OCD. Now I have 3 radii, okay? OC, OD, and OA. Now, I have a chord as well. CD is a chord. But any segment with endpoints on the sphere, such as this one here, which is E and F, is a chord. It goes through the center of the sphere and has endpoints on the sphere. If I would extend this chord out through F, then what I have is a secant. Anything that contains a chord and goes beyond the sphere is a secant. And we have tangent as well. A tangent will touch the sphere at exactly 1 point. And my board's a little slow, so it's hard for me to move things around. So if it touches the sphere at exactly 1 point, then it's a tangent. All of these words translate from circle also to sphere. Okay, a couple more pieces of vocabulary and I am done.
Wait, definition of a sphere.
I did. You guys were talking. Okay, I didn't write it down, but I did say it. The definition of a sphere is a set of all points in space that are that distance of your radius, that specified distance from a single point, which is your center. Okay? Now, Congruent circles. Congruent circles are circles with congruent radii. If two circles have the same radius, then they will be able to lie one on top of the other and everything line up. That's the idea behind congruent. So congruent circles are circles with congruent radii. Same thing for congruent spheres. Spheres with congruent radii will be congruent spheres. Concentric circles. Branson and Dustin, you need to stop talking now. Okay. Notice the word center in there. Concentric circles, con means like centers. Concentric circles are circles that have the same center. So, if I draw concentric circles, what type of shape do I end up with when I draw concentric circles?
Oh, bullseye.
Those are concentric circles. They're circles that share the same center.
Radii. And what's the bottom one?
Circles with the same center, concentric, like center, concentric circles. Concentric spheres would be the same idea, circles with, or spheres with the same center. Concentric.
No, congruent.
Congruent circles. Circles with congruent radii.
So look like that, right?
No, this doesn't have congruent radii. They have the same center. Congruent circles, here's the radius of this circle. If I would draw another circle with that radius, I would be drawing a circle. Exactly. Congruent, remember, means you could lay one on top of the other, and for some reason it's not allowing me to do this. So I'm going to clone this. These two circles are congruent. You could actually place one on top of the other. Okay?
So that's it.
These are concentric, these are not concentric. The top ones are congruent, but not concentric. Okay, our last idea deals with the words circumscribe and inscribe. Okay, you know, it's a very common thing that when I bring up this word, I'm teaching high school kids, right? Okay, so this is nothing that has not happened every year for the past 13 years. Okay? We're not worrying about that. This is made up of two words. The word circum means about or around. The word scribe means to draw. So what do you think the word circumscribe means? To draw around, or to draw something about something else, right? So, if I want to circumscribe a circle about a polygon, here we have a triangle. If I want to circumscribe a circle about that triangle, I'm going to draw a circle around the triangle. And that circle is going to go through all 3 vertices. So here I draw a circle around the polygon, trying to picture where the center would have to be so that I can draw a circle that goes through all 3 vertices. Any triangle can be circumscribed. But if you went to a quadrilateral, not every one can be circumscribed. And then you could start talking about which quadrilaterals can be circumscribed. Okay. Now, that's the word circumscribe. We also have the word inscribe. Again, the word scribe means to draw. The word inside, right? So here we're drawing something inside. If you're going to inscribe a polygon in a circle, it's one word, so is circumscribe actually one word. Inscribe a polygon inside a circle.
So what is that?
That means that you're going to draw a polygon inside the circle.
So I would circumscribe. I think that's like
Here, we drew the polygon first, or polygon was there first.
We need to draw a circle with those points.
Uh-huh.
Circle those points.
Yes, the circle must go through those points.
Okay.
Hold on here. So, is the outside?
It's called circumscribe.
I know, but it's like, inscribed.
Inscribe, circum means around. That means the circle's outside the polygon, so to speak. Inscribe means that the polygon is going to be drawn inside the circle. Okay? So, polygon is there first, and the circle is drawn through the vertices around the polygon. Inscribe, the circle is there first. This is the last one. The circle is there first, and the polygon is drawn inside the circle. So I start with the circle. And then I'll put a quadrilateral inscribed in the circle. How do you think I have to inscribe the quadrilateral in the circle? Yes, each of the sides must be a chord of the circle. In order for me to inscribe a polygon, each of the sides must be a chord of the circle. If it helps you.
Side, circle.
A to draw side.
Yeah, inscribe a polygon inside a circle.
So it's like left.
This is then
That. Yeah, that.
Yeah, that's what
to draw inside, is what inscribe means, to draw inside.
I said polygon.
Okay, the circle is there first, then a polygon is drawn inside.
Circle first.
Each of the sides is a chord.